Hello everyone, welcome back to Bytes of CSE. So in this lecture, we will be learning about SQL basics. So this is going to be a hands-on tutorial. Actually, I had done the tutorial before, but the audio quality was not good. So I had to redo once more. So the best part is I can add a few more details to this video, though this video will not cover the SQL in depth. It will only consider those statements which are a must know for any computer science engineer. If you like to ace your exams or if you like to ace those interviews, like, you can't back down on any of these statements. These are the must know kind of statements. So in the data definition language, I will be covering how to create a table, how to insert values into that, how to update the values, and last time I did not cover the deletion. I intend to do that in this lecture too. And in your data manipulation language, I will be doing the select queries, the wildcards, how to union, join, and group, and also the case statements. So let's get started. So in this particular lecture, I will be considering these schema where there will be three tables. First is the department table, which will contain department ID as the primary key, department name, and a manager ID, and then an employee table, which will contain employee ID as the primary key, employee name, employee city, street, and department ID. And this department ID is going to be the foreign key to the table department on this department ID attribute. Basically, this value, whenever you're trying to enter a value in your employee table regarding the department ID, that value must be present in this particular table, the department table. And then finally, we have a works on table, which will contain employee ID and project ID both as a primary key, since one employee can work in a number of projects, and of course a project will have a number of employees working for it. So basically, the relation between a project and an employee is many is to many. So naturally, in the works on table, both employee ID and project ID has to be the primary key, and then we have a shift and an allowance. Now, if you're not sure what a primary key or a foreign key is, I would highly recommend you to go through a lecture where I have covered the keys. So I have already created the department table and have filled the table. But worry not, I will be doing the employee table creation and the works on table creation. So from that, you will get an idea that how this department table was created. So let's get started. Now in this lecture, I will be using the SQLite 3, which is already installed in my system. I will access that through the command prompt, but these syntaxes will work well with all the SQL database software is available, like the Oracle, MySQL, SQL Server, and so on. So now when you are creating a table, like SQL uses English-like statements for running these commands. So when you are creating the table, the command to do that is create. So create table. Then you have to write the name of your table. So first we'll be doing the employee table. So employee. Now you can continue in the same line, but it looks better if you move to the next line. So I will be moving to the next line. I will have to put the first bracket, and inside this bracket will contain the name of the columns, the data types, and everything you need to mention about the column. So the first column which we will be creating is the employee ID column. So in short, I will be mentioning that as emp ID. Then we have to mention about, after giving a space, we have to mention about the data type that the employee ID column will be, or the values contained in your employee ID column will be. So it will be, in this case, a string like data containing alphanumeric, so that is the varchar. Now fear not if you are not sure what this varchar is. For now you just know that this is a string kind of a variable, and in varchar you will have to mention about what would be the maximum number of characters that your string will contain. So let that be say 12 in our case. And I will be handling with the data types in SQL, the supported data types in SQL, in a separate lecture. I don't intend to make this lecture very long. It will be a long lecture anyways. So now I have to mention that since employee ID, as I said, was the primary key, I will need to mention that, and I will just write primary key. So this lets the compiler know that this is the emp ID. This is a column emp ID whose name is emp ID, which and the maximum number of characters contained in this variable in this emp ID value will be 12, and this emp ID is a primary key. So of course, whenever you're trying to add a null value to this table for your emp ID, this will throw an error. So now I put a comma, and this would mean that everything that I had to mention about this column emp ID has already been mentioned. Now I move on to the next column. So next column will be the name of the employee. So let that be ename. Again, it will be a varchar, which is say 30. And we don't need to say anything about emp name, ename in our schema. So I move on to the next column, which is going to be, I think, let me show you, see, okay, first is the city, then the street. Okay, so now we have the e city. Let that be a variable character, say 25, and we have an e street, which is again going to be a varchar, say 33. And finally we have a department ID. Now this department ID is supposed to be the foreign key that references the table department. Okay, so we will now enter details about the department ID. So this is the dept ID. Even though if it is a foreign key and it actually contains value from another table, you will still need to mention the data type of this department ID, which I have denoted as dept ID. So let that be a varchar, say 15. Now in order to mention that this is a foreign key, this is the simplest actually implementation of foreign key. I will be doing a separate lecture on DDL, or the data definition language, where I will be showing you other ways of mentioning a foreign key. So this is the easiest way of doing it. So dept ID varchar 15. Now since it references the department table, so I will write like references. Now I have to mention the table name, which is department in our case. And now within bracket, I will mention about the column name of the table to which it references. So in my department table, it is entered as dept ID itself. So I write dept ID, and now I'm done with this employee table. I will close the bracket. Everything is done, and just like your C statement, any group of statements or any statement ends with a semicolon in SQL. So now when I press an enter, I find this SQL light blinking. So that means that employee table has been created. So if there is a success, it will not show me any message. Now let me try to insert some values into this table. Now there are two ways of doing it. The shortcut way, or the shortest way of doing that, is insert into, see, it's just like an English statement. Insert into, now we have to mention the table name. Insert into employee. Then values, we are inserting actually values, so insert into table name values. And now within first bracket, we will be writing those values Now the order in which the values are to be entered in this case will be the same in is the same order in which you have created the table. So emp id was the first one, then ename, then ect, street, and dept id. So in the same order you will have to enter the values. So first goes the emp id. So let that, now since it's a varchar, the data type, you will have to use quotes. So it will be like E say 11Z9, something like this. Then we have E name. Let that be say name 1. Then we have ACT. So let that be city 1. Then we have street. So oh, sorry, I forgot the quotes. So street 1. And then we have dept id. Now this dept id has to be one of the values that is already present in our department table. So I think I have this D0001 as a value. So let me check. And okay, this has been inserted. Now till now we haven't found any feedback from their site, SQLite, that a table has been created or an employee value has been entered. So let me check that if at all a table has been created and this value has been inserted. So in order to do that, we are trying to select all the values that are present in the table. So in order to select a value, naturally we will be using this word select. And in order to select all the values, we will be adding this star sign, which means everything from the table name. In this case, it's employee. And now see, it is already there. So an employee table has been created, and these are the values that are being entered into the table for now. Now I'll show you the next way of inserting into a table. Now say you have forgotten the order in which the columns were written while you were creating the table. But you know the exact name of those columns, and now you would like to insert a value into that table. So what you will do is insert into employee. Now after you mention employee, you start a bracket thereafter, and in that bracket you start writing the column's name in the order in which you remember. Say you remember that there was something like an emp id, then there was some department id, then of course the employee had a name, and the employee lived in a street, and there was a city 2. So then you close the bracket, and then you will write values, and now in this bracket you will enter the values in the order in which you have mentioned the columns here. So this is going to be this won't fit in one line, so I'm just navigating to the next line. So values emp id, let that be this. Then we have to mention the department name, let that be D001. Then I have to put in the name, let that be name 2. And then there is street, so street 2, and then city 2. And I'll be finishing off with a semicolon, and this must have been accepted. Now I do the same select statement, and see, now when you when the data is retrieved, see, it is first the name has been first employee id is selected, then the name, then the city, then the street, then the department. Now we will be needing some more values into our table so that we can work with our data manipulation language. So for that I will be copying and pasting. I already have some values which I will be inserting, literally copying into this. So now let me move on to the works on table. So here we will have employee ID, project ID, shift and allowance. Okay, so the same thing, create table works on, then we have emp ID. Then what we had to do, we had to mention about the data type, then a comma. Now here say emp ID is a primary key, and I was supposed to enter that information in this after varchar itself, but I will show you a different way of doing that also. So let me show you that. Now we move on to the next column. So that is going to be the project ID. So I am showing that as PID varchar say 15, and then I have shift. So shift, this is again going to be varchar say 18, and then I have allowance. Now allowance is a number, or actually it's the money that the person gets. So that data type will be numeric. 6 comma 2, this comma 2 mentioned that how many points will be after the decimal, that is allowed here. Now let me mention about the primary key. So I will write primary key, and within the bracket, the first bracket, I will be putting in the column names which are considered for the primary key, and each column name will be entered by a comma separator, like emp ID, then I put a comma, then PID. I will also like to mention that when the database, the one who's actually putting in the value, when he is trying to enter the value for the shift, it has to be morning and evening, and no other value is allowed, like morn, eve, or am, pm. No other value will be allowed. So for that we will be adding in a constraint, and that constraint is known as a check constraint. So check. Now what do we check? We check a column name or a particular column. So we write the name of that column, shift. Then that shift is supposed to contain only two values, morning and evening, and we have to mention that using the in. So check shift in morning and evening. I close this bracket, I close the, and now I close this create table bracket and I put a semicolon. And now let me let me show you how this check constraint actually works. So let me try to insert some values into the table. Insert into works on values, say this. Then we have to mention the PID, say this is your PID. Then let me put AM as my shift. I'm not using morning, I'm not using evening, but I'm using this AM. And then an allowance, say this, and that's all. And now let me try to insert. See, it will throw an error like this. Check constraint failed, shift in morning, evening, and 19. So you need to check that your shift has to contain either morning or evening. So I had actually entered AM, and now it has thrown an error, a runtime error. So now I will be adding in some values to this table, which I will be copying and pasting from here, from my notepad. I don't want to unnecessarily waste my time. So okay. So that is done. So now when we are trying to, let me just show you some other ways of using the select statement. So now we actually what shall I say? We selected all the values from a table. So first, let me just show you what the department table contains. So select star from department. So this is what your department table looks like. So say you would just like to select some particular values for particular column values from your department table. Say you would like to select, in that case, in place of star, we will be adding in those column names. So let us consider, say, department ID and department name. So let me just see once more where the department table contains. Okay, so this is actually the department table. So I used dept ID as the ID and manager ID and dept name. Okay, select dept ID, comma, dept name from department. So here it doesn't matter how many columns you are actually using, actually you're trying to retrieve. You will be retrieving, you will be mentioning those columns using a comma. So now it will just show you the department ID and department name. Suppose you're trying to get the department ID and department name of a manager whose ID is this. So in that case, the statement will be like select dept ID, comma, dept name from department. Now I said that select those select those two attributes, dept ID and dept name, from department where the manager ID is this. So since it's English like, it will be like where manager ID equals to, now this is manager ID is also varchar. So let me find out this one and see, this and marketing, this is mentioned, this is same as this. Actually I retrieved this row without this manager ID. Okay, now let me play around a little bit about the wildcard characters. Now say you remember that the department name you were looking for, it started with M, but you don't precisely remember what the name is. So in order to retrieve queries like that, we use a wildcard. Like, so let me select everything from the department. So select star from department. Now the department name was something that started with M. So where dept name, so department name was like, it started with M, so we will be using this like word, like. Now it started with M and it ended with anything. You don't know what came after this M. So this anything is denoted by percentage. Now let me see what it gives back. So see, everything that started with M, like mining, maintenance, metallurgy and marketing, that has been selected by this query. Let me show you some more. Like say you remember that your department name had N somewhere, but you don't remember the name, of course. So select star from department where dept name, like, so it contained N somewhere. You don't remember if it contained N in the end, N in the middle, N in the first. So in that case, you will, so anything before N and anything after N. So you put N in the middle and you add these two characters here. And now see, mining contains N, in fact 2 N's, maintenance contains N, network contains N, marketing contains N, and design also contains N. So you have these as your result. Now the last thing I'll be showing you is, say you remembered that it ended with ing. So you precisely remember that it ended with ing, but then you don't remember what came before that. So in that case, you will be doing like select star from department where debt name, like, so there was anything in the before ing, and you don't put this anything sign here because you precisely remember that it ended with ing, and now you have mining that ends with ing and marketing that ends with ing. So that's all you need to know about the wildcard for now. I think I have covered everything. If not, I'll be doing a separate video. Okay, now we will be considering 5 important queries which is helpful and which pretty much covers a huge range of queries that you might be encountering in SQL. So first is, you need to find out the name of the employees who have not been assigned to any project. So coming back to the table, you have an employee table which contains all the name of the employees, and you have a works on table where whenever an employee is assigned a project, an entry is made on this table. So if an employee has not yet been assigned a project, his or her name will be found in this table, in this employee table, but will not feature in this works on table. So you will have to find out or retrieve the name, the ename column of the employee, where the employee ID is found is not found in this table. So let me show you how it works. Select ename from employee where EID, I think that was EID, right? Or did I do something else? Just a moment. Actually, I don't want it to throw up unnecessary errors. It just emp ID. I think it was emp ID, not EID. It was EID, emp ID. Where emp ID, so it is not in the works on table. So where emp ID not in, select emp ID from works on. So see, these two names were the first names that I used when I was showing you how to insert a particular value to a column, a particular value to a table. So name 1 and name 2, of course, they weren't assigned any project, and we also have these two names, Priyanka and Kavya, who also were not assigned to any particular project. So we have 4 names showing up here. Now the next query says, find out the allowance and employee ID of all employees working in project P001 morning shift and project this in the evening shift. Now, to find out the employees working, the name, allowance and employee ID of the employees working in project P001 and morning shift, we use the where clause, right? So let me just tackle the query in 2 different statements. So let the first statement will be like, select emp ID allowance from works on. So here comes the where clause. So where PID equals to P0001, I think P0001 was the thing, yeah, P0001. And since we have another constraint, that is has to be a morning shift, we just add in that using the and shift equals to morning. So now if I do that, we have these as the result. Now we have another select statement, select emp id comma allowance from works on where PID, that is a part 2 of this query, which says that we need to select those from project P0007 and evening shift. So PID equals to P0007, and now here you won't be using comma. If you had even some other constraints, you have to use this AND statement. And shift equals to evening. So now you have these two throwing in. So basically I want the both to merge into one result. So a way of doing that is using the union clause. It will be like you will be selecting this. Let me just select this. I haven't used the semicolon here. Then I have to join the two, so I will be using this union. Oops, sorry. Okay, let me do it once more. There was a typo. Now I have to put union. Then I will select the second SQL query that I have shown you. Now I will be finishing off with this. Now see, let me show you the results. It contains 1 2 3 3. This also contains 1 2 3 3, 1 2 3 9. This one contained 1 2 3 9, so 1 2 3 9 is also there. 1 2 0 9 is present here. It is also present here, and then 1277, which we checked here, is also present here, and 1780 is found over here. Now, truth to be told, there are other ways to also get the same result, but I actually had to show you that how this union statements work, or what the union statement does. So I have used the union statement for this particular query. Now there are fine things about union which needs to be told, but I will be doing another lecture on union, union all, and statements like that, and I will be doing that, tackling that in that lecture. So now let me move on to the next query. Find out the number of employees working in each project. Now let's get back to the works on table. So we have to find out the number of employees and not the employee ID. And that is also for each project. So we have to group the project according to the IDs. Then we have to find out who are the employees that are working for each project, and we actually have to find the number of employees. We have to count the number of employees under each project ID. Now it seems like a lot of work, but not in SQL, because there's an easy way of doing this. That is, we will group the project IDs and we will be finding the count of employee IDs for each project using a function, that is an aggregate function, which is supplied by the SQL. Let me show you how. Select. Now just to make it show you or make the query look nice, I will also be considering the project ID. So select PID comma. Now we have to find not the employee ID but the number of employees. So I will have to find the number or count of the employee ID. So there is a function called count which is supplied by SQL. So count, and that count will take as input the emp ID from works on. Now we will need to group by PID. So we have project 1 where 5 people are working, in 2 5 people, 3 5, in 4 6 people are working, in 5 4 people are working, and in 7 2 people are working. Now okay, so the next statement, the next thing that we need to deal with is we have to find the projects where more than 4 employees are working. So naturally what we do in usually the select statement, we use the clause where. So first we move on to that. Before we move on to that, so the first 2 lines will be the same, select. Then we need to group by using the project ID. And now we have to, in general, we used the where clause, right? But seems like when you are using group by, SQL does not support this where clause. Instead, the where becomes having. So having, we need to select those where the number of employees working is greater than, I think 5, right? Now greater than 4, okay. So having count emp ID greater than 4. So now you see P0005 and P007 has been filtered out from your query. Now I will like to show you one more thing which I forgot to mention when I was doing the basic select statements. So let me select the name of the, or the the name, the name of the employees, or the ID of the employees from works on. So let me select emp ID from works on. Now see, same ID is selected for a number of times. See here, E3362, again 3362, again 3362. So if you are just trying to find out that who are the employees that are actually, or which are the employee IDs that are working in this, who are the employee IDs who are assigned a project, you will be using something like select distinct emp ID from works on. Now here you see you won't have any repetition. So when you like to avoid repetition, now since emp ID was not a primary key but a part of the primary key, so naturally you have these the same employee IDs occurring more than once in the select emp ID from works on query. But when you are selecting only, if you like to select only the distinct values, you will use the distinct keyword. Okay, now back to the queries. So finally now we have find the department manager's name, total allowance earned by the manager from the projects. Now here, so first in order to find out, you will have to group the projects under the manager. So here you will have to group the project and the allowance under the manager, and you have to take a sum of the allowance for each manager. Now here the works on contains employee ID and not the manager ID. So the manager ID is held by the department table. And this department table, though I haven't mentioned it explicitly, but manager ID is supposed to be foreign key that references the employee table, because a manager is also an employee. So naturally this manager ID is supposed to be present in this employee table too. So now this manager ID references this employee ID. So now in order to find out the what was it once more in order to find out the manager name, we will need to get that from the employee table by joining this department and employee using this key manager ID equals to employee ID. And now again we have to join employee and works on in order to find out which are the project and what are the allowances the manager is earning from each project. So let me show you how this works. So we have to actually use all the three tables, the information contained by all the three tables, in order to get to this query. Find the department manager's name and total allowance earned by the manager from the projects. So now let's get started. Select e-name. So it's not a manager name, it's actually the e-name that you are trying to find out. Sum. Now here we are taking the sum. The count was to count the number of people, but in case we are actually taking a summation of the allowances, so sum aggregate function is used, which will take as input the allowance from say we start from employee. Now we need to join. Let us join employee and department. Inner join department on. We inner join on the two. Here we are not joining on the department ID, but we are joining according to the manager ID and the employee ID. We are taking these two attributes together. So on employee dot emp ID equals to department dot manager ID. Again we have to join. We be using inner join. I will also be doing a lecture on join, so don't worry about that. So inner join, we have works on. So here we will be joining employee.empid with works on.empid. So inner join works on employee dot empid equals to works on dot empid. Now we have to group according to the empid, not the manager ID. So we will be using group by let me do like works on dot so now you have these are the managers, Navya, Suresh, Bhavesh, and here you will be finding what are the aggregate sum there. So like Adesh is working on more than one departments or a number of projects. He earns quite a huge amount. Then Nikhil also has and Shan. So this is what you get as the result. Now comes the final query, which says that enhance the allowance of employees by 10% of those earning less than 1500 and enhance the allowance of employees by 5% of those earning more than 1500. So if the person earns less than 1500, he gets a 10% hike. If he earns more than 1500, he will get a 5% hike. So before I move on to this particular query, so this is actually we are trying to update the value. So first let me show you how to update a particular value. Say we are what to say, let me try to update a different table. Say update, let me just select all the select star from department. I will be doing something with the department. Okay, um, let me update this value of this department name HR into human resources. Instead of using HR, we'll be using the full form. So in order to update a table, we will be using this update statement, update, then table name. Here the table name will be department. Then we have to set the value. We are setting the value of this depth name into human resources where the department name is HR. So where depth name equals to HR. So now if I select the department, see, instead of HR we have human resources. We had HR here and now we have human resources here. So this is how a basic update query looks like. So update table name, set attribute name equals to something. Now this where clause is optional. If you like to update all the values in a particular table, you will just, the where clause will not be needed. But since we were trying to update only the department name of HR to human resources, we will be using this where clause. So where, and it follows the usual filter attributes which you need to use. Now here you see we have it's a little bit different because we have to enhance 10% for those earning less than 1500 and 5% for those earning more than 1500. So there is, we of course we could use do that in two separate SQL statements, like update works on set allowance equals to this, where allowance less than 1500, and then in the second statement we could have written like in update and so and so. But I would like to do that in one single SQL statement. So in this case we will be using the case statement. So before I move on, let me show you something like select star from works on where allowance less than 1500. So these were the allowances, and select star from works on where allowance greater than 1500. So these are those things. Now we will be updating. So let me show you how we do that. So update works on set allowance equals to, now we will be using the case statement. So we will be using the keyword case allowance, that is we are going to use this particular column name as the for the case statement. When allowance less than 1500, then allowance into, so they will be getting a 10% hike. So 0.1 else allowance. So now for the rest they will be getting a hike of 5% allowance into 1.05. So we will be ending the case and also the command. Now let me show you. So this is what we had so far. Select star from works on where allowance greater than 1500. So now see, you will also be getting values in decimals, which shows that this has been updated, where all the values were in this. So let me just find out where for this one, select. So E3760 had an allowance of 1233. So select select star from works on where emp id equals to Control V. Okay, see, so she worked in so many projects, and see, it has been updated. So the final thing which I would like to show you is the delete statement. So first of all, you might need to or you might want to delete tuples from the table which matches a certain filter. Say we are trying to delete all the entries about this employee from the works on table. So we will be using delete statement. So delete from, we are deleting from a table. So from works on where, here the where clause works, where emp id equals to E 3760. And now let me try to find out select star from works where emp id equals to this. And see, it shows no column because this value does not exist anymore. Now if you like to delete everything from a table, say let me try to delete the entire works on table. So in that case you will be doing like delete from works on. Now let me select star from works on. I shows you nothing because this does not exist. I mean, or no tuples for this table exists. Now the next thing which we will be doing is, that is the last command I'll be showing you. Say you are trying to delete the entire table and the content. Here the table exists but the content does not. But you are trying to delete the entire table. Say let me delete the entire department table. So in that case another statement is used which is known as the drop command. So now drop table department. Now let me try to select star from department. See, it shows an error like no such table department. So the entire table has been deleted from the schema. So that was all about the basic SQL queries which I have done in this lecture. If you've liked this lecture, please give me a thumbs up and share it with your friends. And I will be coming up with more hands-on tutorials. So let me know if you have any more queries, or if you have a particular thing that you need to know or you want me to put up a lecture on. So that's all for today. Thank you for watching. Goodbye.